Hey guys, so let's start 4.3 part 2. It says first identify the parent function and transformations of the equations below, then graph each equation and state the domain and range. So first things first, on number 1 here, my parent function, it's actually a fourth root. So I'm going to kind of compare that to the square root. Any of my even roots are very similar. So my parent function is the fourth root of x. But it doesn't have just a plain x. They currently have the fourth root of 8x. So that transformation has to do with pretty much the exact opposite. Everything that's inside the function with the x does the exact opposite. Usually multiplying by 8 makes things bigger. This is actually going to do a shrink. It is with x, so it will be a horizontal shrink by 1/8. All right, so then, like I said, it's very similar to the square root graph. By that, I mean, it will still kind of have the same basic shape. It'll just be a little more steep. So the domain and range are the same as my square root function. Domain is all the x's greater than or equal to 0, and the range is all the y's greater than or equal to 0. All right, so let's get some specific points. And we're probably not quite as familiar with doing a fourth root, so I'll use the calculator here. We've got, like I said, 0 is probably the lowest number I can plug in. So on your calculator, there may be a fourth root button. For me, I can go to the math menu and I can do any xth root that I want. So you can also, in a scientific calculator, if it doesn't have some, x root, you can raise it to an exponent. In our case, I'm going to do 8x. I'm plugging a 0 in for my x, so like 8 times 0 to the 1/4. A 1/4 exponent is the same thing as a fourth root. All right, so I plugged in a 0 for my x, I got a 0 for my y. So it is the xy point 0, 0. So there's my first point. Next up, let's plug in, I don't know, maybe like a 2 or something like that. I know I'm only plugging in positive numbers. I can't, my domain, it doesn't include any negative numbers. Okay, so if I sub in my 2, okay, that actually ended up with 2. I got the point 2, 2. So does that mean I'm going to get a straight line? I don't think so. I think it should be a curve. So let's get another point here. Let's see, am I going to get a pretty whole number if I plug in the next even? If I plug in a 4? Let's see. Okay, not such a pretty whole number. It's a little over 2. When I plugged in my 4, I got like a 2.37, yada, yada, like 2.4, about there. Okay, should I try 6? Let's see if this works. I'm choosing even numbers. You can choose whichever ones, as long as they're greater than 0. All right, so even when I subbed in my 6, I still got like a 2.63, yada, yada, a little over 2.5. So it's getting really kind of leveling off here, increasing still, but not by much. Okay, so there is my graph. That was an even root, so it was a fourth root. This one is a fifth root, so an odd root. It's my parent function, the fifth root of x. And the transformations, I think I got 2 transformations going on here. The negative, this has to do with a vertical. It's outside of the fifth root, so it has to do with y values. And that negative has to do with a vertical reflection. All right, and then this +1 here, that is under the root with the x, so it will go horizontally as x's do. We are going to shift the entire graph to the left by 1. Or you can say translate to the left by 1. All right, so again, it's a very similar shape to any odd root. So my cube root looks something like this. Oh, maybe because I'm not good at drawing this, but it's very similar to this. So I'm gonna have that same basic shape going to negative infinity and positive infinity. So like all real numbers for my domain and all real numbers for the range. Same on all of my odd roots here. Let's get some specific points then. Again, we might not be quite familiar with a fifth root graph. We do know a cube root graph though. As far as the fifth root goes, I can do a 1/5 exponent again. So I can do a negative, let's see here, maybe I'll plug in like a -6 plus 1 is all under my fifth root. So like my 1/5 exponent. All right, so at -6, I got the y value of like 1.4 if I round it. So not even 1.5, it's pretty shallow here. At then maybe I'll do like a -3. Let's check this out. Okay. All right. Oh, it's a positive, excuse me. It's positive. So this last one I graphed incorrectly. I should have had a positive 1.4 y value at a -6 x value. Now I'm gonna have like a positive 1.1 y value at the -3 x value. Okay, so it was a little off here. -6, 1.4, so a little short of a half. And then at -3, we had the 1.1, barely over 1 here. All right, let's try at -1. I'm doing a -1 just because I think it'll be -1 plus 1 is a nice pretty 0. All right, so this one gives us, like I said, straight up 0. Good. So at -1, I got the 0. And let's see if I plug in a 0, what does that give me? Oops. All right, so that gave me a -1. It's kind of nice. That actually makes me think if I was here at -2, I bet that would have given me a nice pretty whole number. Yeah, at -2, I got a positive 1, so that actually does give me, there we go. So I'm kind of seeing the shape here. It's going to be this really steep curve right in the middle here. It's like really shallow at the end. Then it's got this steep curve in the middle. Let's see, I'm going to plug in like a couple more numbers here on the right side. Maybe I'll plug in like a positive 1. All right, so it's like my -1.1. Barely over -1. Maybe I'll plug in like a, I don't know, 4 or something. Just trying to see the shape here. I guess it should be a 4 plus 1 instead of 1 plus 4, but same thing. Okay, so this gives me a negative like 1.4. Okay, all right, so here's kind of my shape. If I connect these dots, it should look a lot like that cube root function. Just kind of like it got stretched out. All right, so next up, this one is a little different in that it says x equals blah, blah, blah. So I'm going to say my parent function is like x equals y squared instead of y equals x squared. So if the y is squared, it's kind of this parabola, but on this side. Let's see, it's facing to the right. Transformations, let's see. I've got like 3 different transformations. The negative itself, this is a, I should say not vertical. I swapped my x and y, so that's actually going to be a horizontal reflection. All right. And then my next one, the 2 here, multiplied out front. It's not squared like the y is, so it's not going to go vertically like y's do. It's going to go horizontally like the x does. And so this will be a horizontal stretch by 2. All right, and then the -3 again on the outside, it's not all squared like the y is, so it's going to be like the x is. It'll go horizontally, either to the left or right. Now, usually I make my horizontal stuff do like the exact opposite, but since I kind of swapped my x's and y's, I'm going to have it treat it like a y. It's going to do, as usual, negative x's go to the left, so this is actually going to shift my entire graph to the left by 3. Or you can say translate to the left by 3, same thing. All right, so again, my parent function looks kind of like this, which means if I can probably do the shifting left by 3 pretty easy. Instead of 0, there's 1, 2, 3, so it's going to look kind of like this. And then a horizontal reflection, so it's going to go horizontally, it'll face the opposite direction. So it's actually going to be this way. So I've kind of taken care of these two, but the horizontal stretch, let's see about this. The vertex will stay there, but usually like 1 squared is 1, right? But I'm going to do a horizontal stretch. So I'm going to do 1 times 2. So 2, I'm going to go up 1 over 2. And this will be a parabola, so I'm going to do the same thing below it. Let me get these points here. You can do this with the 2 as well. Usually 2 squared is 4, but we are doing a horizontal stretch by 2. I got to do like 4 times 2. So I would go up 2 instead of over 4. I would have to go over like 8. It's going to be kind of off the chart here. But this is my horizontal parabola. These are some specific points it should hit. There we go. As far as I look at this, I can tell the domain, all my x's. I've got no x's over here to the right side of the -3. The domain is going to be all the x's that are less than or equal to the -3. The range, it actually is going up and down slowly, but it is going up and down forever. So all real numbers are the range. All right, there we go.